Hello there. Before we begin, take a moment to settle in. Find a comfortable place to rest, letting your body soften and your breathing slow. There's nothing you need to focus on and nowhere you need to go. This is simply time set aside to be still, to listen, and to let the pace of the universe carry you gently forward. As this story unfolds, you're welcome to stay awake, to drift, or to fall asleep entirely. Everything will continue quietly, whether you're listening closely or resting deeply. Feel free to comment where you're listening in from. When you're ready, let the light fade a little, and we'll begin. Chapter 1. Before Sleep. Had a name. Long before there were animals, long before there were eyes to close or brains to quiet, the planet already moved in rhythms of activity and rest. Earth turned steadily beneath the sun, exposing its surface to light and then withdrawing it again into darkness. This cycle repeated without awareness, without intention, without pause. Day followed night, and night followed day, not as an event, but as a condition of existence. In the earliest oceans, life began not with movement as we imagine it, but with chemistry. Simple molecules drifted, collided, bonded, and separated again. Energy flowed unevenly through this environment. Sunlight penetrated the upper layers of water, while deeper regions remained dim and cold. Even here, before life could sense or respond, the environment itself already offered alternating periods of abundance and scarcity. The first living systems were small, fragile, and easily disrupted. They relied on chemical gradients, thermal stability, and a careful balance between energy intake and structural integrity. These early organisms did not sleep. They did not wake. They did not possess awareness. And yet, they already followed patterns that would one day resemble rest. At the cellular level, continuous activity is costly. Chemical reactions generate heat. Metabolism produces reactive byproducts. DNA accumulates damage simply by existing in an energetic environment. Even the most basic forms of life require moments when activity slows, when repair overtakes growth, when internal systems are allowed to recalibrate. In modern single-celled organisms, these patterns can still be observed. Bacteria exhibit cycles of heightened metabolic activity, followed by phases of reduced function. Certain genes turn on and off in repeating sequences that align loosely with environmental cues, particularly light and temperature. These cycles are not conscious decisions. They are not behaviors. They are expressions of internal stability seeking balance. It is tempting to imagine early life as endlessly active, constantly dividing, consuming, and expanding. But this would not be sustainable. Life that never pauses quickly exhausts its resources or accumulates fatal errors. Even in the simplest forms, survival depends not only on action, but on restraint. In shallow waters, where sunlight reached the seafloor, early photosynthetic organisms experienced predictable changes in energy availability. During periods of light, they absorbed photons and converted them into chemical energy. During darkness, this energy source disappeared. Over time, internal mechanisms evolved to anticipate these changes. Cells began to prepare in advance, storing energy, slowing certain processes, and shifting priorities as night approached. This anticipation marks an important threshold. It represents the beginning of biological timekeeping. Circadian rhythms, as they are known today, did not begin with brains or behavior. They began with chemistry. Molecular clocks emerged as feedback loops within cells, where the products of certain reactions eventually suppressed their own production, creating oscillations that repeated roughly every day. These oscillations aligned naturally with the rotation of the planet. In this sense, the earliest biological clocks were not adaptations to sleep, but to survival. They allowed organisms to optimize energy use, minimize damage, and synchronize internal processes with external conditions. Rest, in this context, was not an action taken. It was a state that emerged when activity was no longer efficient. As life diversified, these internal rhythms became more refined. Some organisms developed heightened sensitivity to light, allowing them to adjust their internal cycles more precisely. Others relied on temperature fluctuations or chemical cues in the environment. Still others maintained internal rhythms, even in constant conditions, suggesting that the clock had become an intrinsic feature of life, rather than a direct response to surroundings. This persistence is important. It suggests that rhythmic regulation offered advantages beyond immediate environmental adaptation. Internal timing allowed cells to coordinate complex processes, ensuring that energy-intensive tasks did not overlap unnecessarily, and that repair mechanisms could operate without interference. One of the most critical processes requiring such coordination is DNA maintenance. Genetic material is constantly threatened by errors during replication and by damage from environmental stresses. Repair enzymes work most effectively when replication is paused. Periods of reduced activity create opportunities for correction, preserving the integrity of the organism across generations. Protein synthesis, too, benefits from rhythmic regulation. Proteins must fold into precise shapes to function properly. Misfolded proteins can accumulate and interfere with cellular operations. Slowing production allows quality control systems to clear these errors, maintaining cellular health. In this way, early life discovered a principle that remains true today. Maintenance requires stillness. As multicellular life had not yet emerged, there were no nervous systems to coordinate rest across tissues. Each cell managed its own timing. Yet even here, coordination began to appear. Chemical signaling allowed groups of cells to align their rhythms, creating collective phases of activity and rest within colonies. This coordination did not resemble sleep as humans experience it. There was no unconsciousness, no withdrawal from the world. But there was a shared reduction in activity, a synchronized slowing that allowed the organism as a whole to function more efficiently over time. Environmental cycles reinforced these patterns. The rotation of Earth provided a reliable external signal. Light faded and returned. Temperatures shifted gradually. Chemical gradients changed predictably. Life learned not only to respond, but to anticipate. Anticipation is subtle. It does not require thought. It requires memory encoded in molecular interactions. When a cell adjusts its behavior before conditions change, it demonstrates a form of biological foresight shaped by evolution. Over countless generations, organisms that aligned their internal rhythms with the planet's cycles outcompeted those that did not. They conserved energy. They repaired damage more effectively. They survived longer and reproduced more successfully. Thus, rest became embedded in the architecture of life, not as a luxury, not as an optional state, but as a necessity woven into metabolism itself. It is important to note that early rest was not uniform. Different processes slowed at different times. Some reactions continued while others paused. Rest was not total inactivity, but selective reduction. This distinction remains relevant even in complex organisms today. Life never truly stops. It shifts focus. As evolution progressed, cells specialized. Some became dedicated to movement, others to digestion, others to sensing the environment. With specialization came the need for coordination. Timing became more important, not less. In simple multicellular organisms, early forms of neural signaling began to appear. These systems did not produce consciousness. They transmitted information about the environment, synchronizing responses across tissues. With this coordination came the possibility of organism-wide states. Activity could rise and fall together. External responsiveness could be modulated collectively. The foundations of sleep were being laid, not by intention, but by necessity. At this stage, rest was still deeply tied to the environment. Light and darkness remained primary drivers. Yet internal clocks ensured that even in stable conditions, rhythms persisted. Life had internalized the planet's motion. This internalization is one of evolution's quiet achievements. Rather than reacting moment by moment, organisms began to carry time within themselves. In environments where light was constant, such as deep oceans or underground habitats, organisms still displayed rhythmic patterns. These rhythms drifted slightly without external cues, but did not disappear. This persistence suggests that internal timing had become essential to biological organization. Energy balance, repair, and coordination all depended on rhythmic cycles. From this perspective, sleep is not an anomaly. It is the culmination of a long process of refinement. It is rest made systemic. It is stillness coordinated across an entire organism. But before sleep could emerge, life had to learn how to pause without ceasing to exist. The earliest pauses were brief and localized. Over time, they became longer and more synchronized. Each step built upon the last, guided by the same pressures that shape all biological systems: efficiency, stability, and survival. There was no moment when sleep was invented. There was no boundary where rest suddenly became unconsciousness. There was only a gradual deepening of stillness, a widening of coordination, and an increasing separation between phases of engagement and withdrawal. As this chapter closes, life remains simple. There are no dreams. There are no nights spent unaware of the world. Yet the seeds are present. The planet turns. Light comes and goes. Cells slow, repair, and prepare. In the quiet repetition of these cycles, something familiar begins to take shape. Not sleep as we know it, but the conditions that make sleep inevitable. As life continued to persist beneath these repeating cycles, subtle refinements accumulated. Within cells, feedback loops grew more stable. Enzymes became more specialized. Pathways that once operated continuously began to show preference for particular phases of the internal cycle. During periods of reduced activity, cells redirected resources inward. Energy was conserved rather than spent. Damaged components were dismantled and recycled. Molecular debris, an unavoidable consequence of metabolism, was cleared away. This internal housekeeping did not require awareness. It followed rules encoded by chemistry and refined by time. Light played a particularly influential role in shaping these rhythms. Photoreceptive molecules allowed cells to respond directly to changes in illumination. When light was present, certain reactions accelerated. When it faded, those reactions slowed or ceased. Over generations, these responses became anticipatory rather than reactive. A cell exposed to repeated cycles of light and darkness does not simply respond each time as if it were new. It begins to expect the pattern. Its internal state shifts in advance, preparing for what is likely to come. This expectation is not thought, but structure. It is memory written into molecular pathways. In environments where light was unpredictable, such as beneath sediment or within turbid waters, other cues gained importance. Temperature changes, chemical gradients, and nutrient availability all served as timing signals. Life proved flexible in how it measured time, but consistent in the need to do so. The emergence of internal clocks reduced dependence on immediate conditions. Organisms could maintain order even when external signals were weak or absent. This autonomy marked a turning point. Timing was no longer borrowed entirely from the environment. It was carried within. With internal timing came resilience. Cells that could pace themselves survived fluctuations that overwhelmed less regulated systems. They avoided running at full capacity when resources were scarce. They avoided replicating damaged genetic material. They endured. Rest, in this expanded sense, became a form of protection. By limiting activity during unfavorable periods, early life reduced exposure to harm. Ultraviolet radiation, temperature extremes, and chemical stresses were less damaging when metabolism slowed. This protective stillness did not require a boundary between awareness and unconsciousness. It existed entirely within biochemical limits. Activity faded not because of fatigue, but because continuation offered diminishing returns. As colonies of cells grew more complex, coordination across individuals became advantageous. When cells shared resources or structural connections, uncoordinated timing could create conflict. Some cells might consume energy, while others attempted repair. Some might divide, while others dismantled. Chemical signaling helped resolve this. Messenger molecules spread information about internal states, allowing groups of cells to align their cycles. Activity rose and fell together. Repair occurred collectively. The organism behaved in a limited sense as a unified system. These early forms of coordination foreshadowed later developments. They demonstrated that synchronized rest improved overall stability. An organism that slowed together survived together. Even at this stage, rest was not absolute. Certain processes remained active at all times. Ion balances were maintained. Structural integrity was preserved. Life continued quietly beneath the surface of stillness. This balance between persistence and pause is fundamental. Complete inactivity would be fatal. Continuous activity would be unsustainable. Life navigated the narrow space between these extremes. The planet itself reinforced this balance. Earth's rotation imposed a steady rhythm that could be trusted. Unlike storms or seasonal shifts, day and night were reliable. This reliability allowed life to align its internal processes with confidence. Over immense spans of time, alignment deepened, internal cycles sharpened, variability decreased, precision increased. The length of these cycles was not exact at first. Early biological clocks drifted. Without external cues, their rhythms gradually lost alignment. But exposure to consistent environmental signals recalibrated them. Light reset timing. Temperature adjusted pace. The planet corrected its inhabitants. This interplay between internal rhythm and external correction persists today. Modern organisms retain internal clocks that can operate independently, yet remain responsive to environmental cues. This dual system offers both stability and flexibility. The early emergence of such systems suggests that timekeeping was among life's most valuable adaptations. Before complex structures, before specialized organs, before awareness itself, life learned to measure duration. And with duration came the possibility of rest as a recurring state. It is worth pausing on the nature of this rest. It was not inactivity imposed from outside. It was not collapse or failure. It was an organized response to internal and external limits. Rest allowed life to endure conditions it could not control. Darkness could not be avoided. Scarcity could not be eliminated, but activity could be adjusted. This adjustment required no instruction. It emerged wherever survival depended on balance. As evolution continued, the benefits of rest compounded. Lineages that refined their timing mechanisms gained cumulative advantages. Their descendants inherited systems already tuned to the planet's rhythm. By the time multicellular organisms appeared, the groundwork had been laid. Internal clocks existed. Repair cycles were established. Coordination across cells was possible. What had not yet appeared was awareness of rest. Sleep, as a subjective experience, remained far in the future, but its foundation was already ancient. The story of sleep does not begin with dreams or darkness. It begins with chemistry learning restraint. It begins with life discovering that survival depends not only on doing, but on waiting. As Earth continued to turn, life continued to pause. Again and again, quietly, reliably, preparing the way for what would come next. As this quiet preparation continued, Earth itself changed. The chemistry of the oceans shifted. Volcanic gases accumulated in the atmosphere. Slowly, over immense spans of time, oxygen began to appear as a persistent component of the environment. For early life, oxygen was not immediately beneficial. It was reactive and potentially damaging. Its presence increased the risk of oxidative stress, threatening cellular structures and genetic material. Yet oxygen also enabled more efficient energy production. Life adapted cautiously, learning to manage both the danger and the opportunity. This new chemical reality reinforced the importance of rest-like states. Oxidative processes generate byproducts that must be neutralized or repaired. Cells that reduced activity periodically limited their exposure to damage. Repair systems operated most effectively when energy demands were lower and replication slowed. The rise of oxygen did not introduce rest, but it sharpened its necessity. As metabolic pathways grew more complex, coordination became increasingly important. Enzymatic reactions depended on precise timing. The accumulation of intermediate products could be harmful if not managed carefully. Rhythmic regulation ensured that processes unfolded in an orderly sequence. Within this growing complexity, cycles of activation and suppression became more pronounced. Certain genes were expressed preferentially during phases of lower activity. Others dominated during periods of growth and replication. These patterns persisted across generations, encoded not as instructions to rest, but as constraints on when activity made sense. The idea of nightfall gained biochemical meaning. Darkness no longer simply removed light. It signaled a shift in priorities. Energy capture slowed. Maintenance took precedence. The internal state of the cell changed in anticipation of reduced resources. In environments where light was absent altogether, such as deep waters or subterranean spaces, internal timing still persisted. Rhythms free ran, drifting slowly without correction, yet never disappearing. This persistence suggests that timing had become essential to organization itself, not merely a response to the sun. At this stage in Earth's history, life remained unaware. There were no sensations to dull, no thoughts to quiet. And yet, the pattern that would one day feel like sleep was already deeply embedded. It existed as a principle rather than a state. That principle was simple. Systems endure when they alternate between engagement and restoration. As multicellularity became more common, internal division of labor intensified. Cells specialized further. Some focused on energy acquisition, others on structural support, others on signaling and coordination. With specialization came interdependence. Timing errors in one part of the system could disrupt the whole. This vulnerability favored stronger synchronization. Chemical signals grew more precise. Feedback mechanisms tightened. Entire organisms began to exhibit unified phases of activity, and quiet. In these early organisms, external responsiveness fluctuated. Sensitivity to stimuli increased during active phases and diminished during quieter ones. Though still far from sleep, these shifts marked a move toward organism-wide modulation of interaction with the environment. Reduced responsiveness conferred protection. When activity slowed, exposure to harm decreased. Energy expenditure dropped. Internal stability improved. These benefits accumulated slowly but steadily. Over time, lineages that coordinated rest more effectively persisted. It is important to note that this progression was not linear. Environmental disruptions reset conditions repeatedly. Ice ages advanced and retreated. Oceans mixed and stratified. Continents shifted. Life adapted again and again, carrying its rhythms through change. Throughout these transitions, the basic requirement remained unchanged. Life needed time not only to act, but to recover. The emergence of nervous systems would eventually transform these patterns. Electrical signaling would allow faster coordination. Sensory input would shape timing more dynamically. Conscious experience would add new dimensions to rest. But none of this was yet present. Here, in this early chapter of life's story, rest existed without awareness. It existed without darkness as we experience it. It existed without vulnerability or comfort. It was simply the quiet logic of survival. The planet continued to turn. Energy flowed unevenly. Cells adjusted, slowed, repaired, and prepared. Again and again, the same lesson was reinforced. Persistence requires pause. And so, long before sleep had a name, life was already practicing it. As time continued to unfold, the environments that hosted early life grew more varied. Shallow seas warmed and cooled with changing climates. Shorelines advanced and retreated. Chemical compositions shifted slowly, sometimes over millions of years. Through all of this, the fundamental rhythm of light and darkness remained. Life adapted not by resisting these changes, but by folding them into its internal organization. Cells that could not adjust their timing vanished quietly. Those that could persisted, carrying forward internal systems that balanced activity with restraint. The refinement of these systems did not depend on speed. Evolution worked patiently, selecting for stability rather than intensity. The organisms that endured were not those that burned energy quickly, but those that used it wisely. Within cells, energy currency became more standardized. Molecules such as adenosine triphosphate provided a consistent means of storing and releasing energy. This consistency made timing even more important. Energy could be saved for later use, but only if consumption was regulated. Periods of reduced activity allowed reserves to accumulate. They allowed repair processes to proceed without competition from growth and replication. They allowed internal balance to be restored. These periods were not identical across all lineages. Some organisms favored shorter cycles, others longer ones. Some responded strongly to environmental cues, others relied more heavily on internal regulation. Diversity flourished within constraint. What united these strategies was the recognition, enforced by survival, that continuous engagement was unsustainable. As multicellular forms became more complex, internal communication networks expanded. Chemical gradients conveyed information about nutrient availability, stress, and internal state. These signals influenced timing, nudging cells toward activity or restraint as conditions demanded. This communication did not eliminate individuality at the cellular level. Rather, it layered collective coordination atop local autonomy. Cells retained their internal clocks, while aligning them loosely with the organism as a whole. This layered timing created depth. different processes unfolded on different schedules. Some cycles were rapid, repeating many times within a single day. Others were slow, spanning weeks or seasons. Life became a system of nested rhythms. Within this system, rest occupied multiple roles. It conserved energy. It reduced damage. It synchronized internal processes. It stabilized long-term function. None of these roles required awareness. None required sensation. They arose naturally from the constraints imposed by physics and chemistry. As Earth's atmosphere continued to evolve, day and night grew more distinct. The filtering effects of atmospheric gases altered the quality of light reaching the surface. Ultraviolet radiation was reduced. Visible light became more consistent. These changes further refined biological timing. Organisms exposed to predictable light cycles benefited from aligning sensitive processes with safer periods. DNA replication, for example, occurred more reliably when radiation levels were lower. Timing offered protection without effort. The emergence of such strategies reinforced the value of internal clocks. They allowed life to anticipate danger rather than react to it. Anticipation, once established, became difficult to lose. Lineages that abandoned timing lost coordination and resilience. Those that preserved it passed it forward. In this way, rest became inherited, not as a trait visible to the eye, but as a tendency embedded in molecular pathways. As life explored new environments, these tendencies adapted. In polar regions, cycles of light and darkness stretched dramatically. Organisms adjusted their rhythms accordingly. In equatorial regions, stability prevailed, and rhythms remained tightly bound to the daily cycle. Even in environments where external cycles were muted or absent, internal timing persisted. This persistence suggests that rest had become integral to biological identity. It was no longer simply a response to the world. It was part of what it meant to be alive. As internal organization grew more complex, errors carried greater consequences. A single mistimed process could disrupt many others. This vulnerability increased selective pressure for reliable coordination. Mechanisms that enforced pauses became more robust. Feedback loops tightened. Fail-safes emerged. Activity was increasingly constrained by internal checks. These constraints did not hinder life's expansion. On the contrary, they enabled it. Complexity requires regulation. Growth without pause leads to collapse. Through regulation, life learned to scale. By the time early nervous systems began to appear, the groundwork for organism-wide rest was firmly in place. Electrical signaling added speed and precision, but it did not invent the need for pause. It inherited it. Neural activity itself proved metabolically expensive. Without periods of reduced firing, energy demands would overwhelm supply. Here again, restraint ensured survival. The earliest nervous systems did not produce thought. They coordinated movement and response. Yet even these simple networks benefited from rhythmic modulation. Periods of heightened responsiveness alternated with quieter intervals. Sensory input was processed more efficiently when not constant. Signals stood out more clearly against a background of stillness. This modulation foreshadowed later developments. It hinted at the possibility that rest might one day shape experience, not just survival. But in this chapter of life's story, experience had not yet emerged. There were no nights filled with images, no drifting awareness, no sense of time passing. There was only rhythm. Rhythm embedded in chemistry. Rhythm reinforced by the planet's motion. Rhythm carried forward through countless generations. As Earth continued its slow rotation, life adjusted its pace again and again. Activity rose with opportunity. It fell with scarcity. Repair followed exertion. Preparation followed rest. These cycles did not demand attention, they required only persistence. Over geological time, persistence proved enough. Life spread, diversified, and endured, carrying with it an ancient lesson learned in the earliest oceans. To continue is to pause. To survive is to yield, briefly, to stillness. Long before sleep would become a place of dreams, it was already a discipline of life, a quiet agreement between chemistry and time, an agreement kept unbroken as the planet turned. As this agreement endured, life continued to refine how it inhabited time. The repetition of cycles did not produce monotony. Instead, it created stability. Stability allowed complexity to accumulate without collapsing under its own weight. Within stable rhythms, variation could exist safely. Small changes in timing could be tested without threatening survival. Evolution explored these variations patiently, selecting those that improved balance. Some lineages developed shorter cycles of rest and activity, allowing rapid adjustment to changing conditions. Others favored longer intervals, prioritizing thorough repair over frequent engagement. Both strategies could succeed when matched to environment. What mattered was not the exact length of rest, but its presence. At the molecular level, this presence manifested as oscillations in gene expression. Certain genes rose in prominence, while others receded, then exchanged roles as the cycle progressed. These oscillations reduced interference between incompatible processes. Replication demanded precision, repair demanded access, growth demanded resources. By separating these demands in time, cells avoided conflict. This temporal separation is one of life's quiet innovations. Rather than solving problems through structural complexity alone, life solved many through timing. As organisms grew larger, the advantages of temporal separation multiplied. Different tissues required different conditions. Muscular activity generated heat and waste. Digestive processes consumed energy. Structural maintenance demanded patience. Coordinated timing allowed these needs to be met without competition. In the absence of such coordination, complexity would falter. Systems would interfere with one another. Errors would accumulate. Stability would erode. Rest preserved coherence. Even before nervous systems matured, organisms exhibited phases of reduced responsiveness. Movement slowed. Reaction thresholds increased. Engagement with the environment softened. These phases did not represent vulnerability. They represented optimization. By limiting interaction when conditions were unfavorable or when internal repair was prioritized, organisms improved long-term survival. They traded short-term opportunity for long-term continuity. This trade-off remains fundamental to sleep today. As life colonized land, new challenges emerged. Temperature variation increased. Water availability fluctuated. Exposure to radiation intensified. These pressures further reinforced the value of rhythmic regulation. On land, darkness brought cooler temperatures and reduced radiation. Periods of rest aligned naturally with these safer intervals. Internal clocks adjusted to these new conditions without abandoning their ancient foundations. The transition from water to land did not disrupt rest. It adapted it. As terrestrial ecosystems developed, cycles grew layered. Daily rhythms intertwined with seasonal ones. Longer-term cycles emerged, linked to growth, reproduction, and dormancy. Rest expanded in scope. It was no longer solely about cellular repair. It became part of developmental timing. It influenced when organisms grew, when they reproduced, and when they conserved resources. Through all of this, awareness remained absent. Timing operated beneath experience. Life moved through phases without knowing them. This absence of awareness is important. It reminds us that sleep is not primarily about consciousness. It is about organization. Only later would consciousness arrive to inhabit these rhythms. Only later would rest become something felt. Here, in this early world, rest existed without sensation. It was a background condition, like gravity or temperature. The sun rose and set, cells adjusted, organisms slowed and resumed. Again and again, the same pattern unfolded: engagement, withdrawal, repair, preparation. These stages did not require labels. They required only persistence. As geological eras passed, these rhythms became so deeply embedded that they could no longer be removed without consequence. Attempts to override them led to instability. Even in modern organisms, disruption of timing produces widespread effects. This sensitivity reflects the ancient integration of rest into biological systems. The legacy of these early rhythms endures in every living cell. They persist not because they are enforced, but because life cannot function without them. The quiet alternation between activity and stillness is as fundamental as metabolism itself. It is older than behavior, older than nervous systems, older than sleep. As this chapter draws to a close, life remains simple, yet prepared. The stage is set for new developments. Nervous systems will appear. Awareness will emerge. Rest will deepen into sleep. But none of this will replace what already exists. It will build upon it. The ancient rhythms will remain, steady beneath the surface, guiding what comes next. And so the story continues, carried forward by the same quiet principle that has always sustained life. Pause makes persistence possible. As this persistence carried life forward, the quiet influence of timing continued to shape every layer of biological organization. What had begun as simple chemical oscillations now governed increasingly intricate systems, linking the smallest molecular events to the broader patterns of living forms. Within each cell, countless reactions unfolded every second. Left unchecked, these reactions would interfere with one another, competing for space, energy, and resources. Timing resolved this conflict. By staggering activity, cells ensured that critical processes did not collide. This staggering created a natural ebb and flow. Activity peaked, then receded. Repair intensified, then eased. The internal environment oscillated gently, maintaining balance without rigidity. Balance, in this sense, was not stillness. It was motion guided by restraint. As organisms grew in size, internal distances increased. Signals took longer to travel. Coordination required anticipation rather than immediate response. Timing once again provided the solution. Rhythms aligned distant tissues without constant communication. A muscle cell and a digestive cell did not need to exchange messages continuously if they shared a common temporal framework. Each could predict when resources would be available and when repair would be prioritized. This predictive capacity reduced metabolic strain. It allowed organisms to function efficiently even as complexity increased. Environmental cycles continued to provide calibration. Dawn and dusk refined internal clocks. Seasonal shifts adjusted longer rhythms. Even subtle changes in temperature reinforced timing cues. In regions where environmental signals were muted, such as beneath dense canopies or within soil, internal timing proved especially valuable. Life did not require constant external instruction. It carried its own schedule. This independence supported exploration of new niches. Organisms could persist in environments where cues were unreliable, relying on internal order to maintain stability. Over time, internal rhythms diversified. Multiple clocks operated simultaneously, governing different processes. Some cycles were fast, repeating many times each day. Others were slow, unfolding over weeks or months. These layered rhythms allowed life to manage tasks of varying urgency. Immediate responses coexisted with long-term maintenance. Growth occurred alongside preservation. Rest occupied a central place within this hierarchy. It acted as a reset point, allowing systems to realign. Without rest, small timing errors accumulated. With rest, they were corrected. This corrective function became increasingly important as organisms aged. Wear and tear accumulated. Repair required uninterrupted intervals. Timing provided them. Even before the emergence of complex nervous systems, aging influenced rhythm. Older cells adjusted their cycles, favoring maintenance over expansion. This shift improved survival. Such adjustments hint at the deep integration of rest into life's strategy. It was not merely a response to fatigue, but a structural feature of longevity. As ecosystems grew more interconnected, synchronized timing extended beyond individual organisms. Populations aligned their activity cycles. Predators and prey adapted to one another's rhythms. Entire environments pulsed with coordinated motion and stillness. These larger patterns emerged without planning. They arose from countless local interactions, shaped by shared constraints. Nightfall quieted landscapes. Activity condensed into specific windows. Energy use became predictable. Repair proceeded across scales. Even in the absence of awareness, the world began to resemble a place that slept. Not in the human sense, but in rhythm. The sun dipped below the horizon. Temperatures fell. Chemical reactions slowed. Life adjusted its pace. This adjustment was neither dramatic nor complete. Some organisms remained active, others withdrew. Diversity persisted within order. What unified these responses was respect for limits. Limits imposed by energy availability. Limits imposed by chemistry. Limits imposed by time. Life thrived by acknowledging these limits rather than resisting them. As this chapter reaches its final stillness, the groundwork for sleep stands fully prepared. The planet has taught life how to pause. Life has learned to listen. What remains is for awareness to arrive and inhabit these rhythms. That story belongs to what comes next. Chapter 2: When Rest Became Sleep. The transition from rest to sleep did not happen all at once. There was no moment when life crossed a clear boundary, leaving simple rhythms behind and entering a new state of unconsciousness. Instead, sleep emerged gradually, shaped by the same quiet pressures that had guided life from the beginning. Energy conservation, protection, coordination, and repair. As nervous systems began to appear, they did not replace existing rhythms. They layered themselves on top of them. The earliest nervous systems were not designed for thought or reflection. They were tools for coordination. Electrical signals allowed information to travel faster than chemical diffusion alone. Muscles could contract together. Sensory input could guide movement more precisely. Responses could be timed rather than constant. These systems were metabolically expensive. Neurons required a steady supply of energy to maintain electrical gradients. Continuous firing would have been unsustainable. Once again, restraint offered an advantage. Periods of reduced neural activity conserved energy. They limited wear on delicate signaling structures. They reduced noise within the system, allowing important signals to stand out more clearly when activity resumed. At first, these reductions were local rather than global. Individual neural circuits quieted, while others remained active. Reflexes continued even as responsiveness diminished in certain regions. The organism remained engaged with the environment, but not uniformly. This uneven quieting marks an important step. It represents the beginning of state differentiation within nervous systems. Rather than operating at a constant level, neural activity began to fluctuate between modes. Some modes prioritized responsiveness. Others favored internal maintenance and integration. In simple animals such as jellyfish, flatworms, and early arthropods, these fluctuations can still be observed. Activity rises and falls in predictable patterns. Periods of movement alternate with stillness. Responsiveness varies with internal state. These organisms do not sleep in the human sense. There is no clear loss of consciousness, yet their behavior reflects a coordinated reduction in activity that goes beyond simple rest. When disturbed during these quieter periods, responses are slower. Sensory thresholds increase. After deprivation of these states, normal function deteriorates. These features align closely with the defining characteristics of sleep. What distinguishes sleep from simple rest is not total inactivity, but global coordination. As nervous systems grew more centralized, coordination expanded. Larger portions of the organism entered quiet states together. Sensory input was dampened broadly rather than locally. Motor activity decreased across the body. This coordination offered new benefits. By reducing external engagement, organisms limited exposure to danger during vulnerable periods. By synchronizing internal processes, they improved efficiency of repair and integration. Memory-like processes began to emerge. Neural activity patterns experienced during wakeful periods were replayed, reinforced, or adjusted during quieter states. This replay did not require awareness. It occurred automatically, shaped by circuitry and timing. Such processes improved learning and adaptation. Behaviors became more refined. Responses became more efficient. Sleep, in its earliest forms, was not about dreaming. It was about refinement. As organisms diversified, sleep-like states diversified with them. Some species developed long periods of reduced activity. Others adopted shorter, more frequent intervals. Some remained partially responsive. Others withdrew more completely. Despite this diversity, the core features persisted. Reduced responsiveness, coordinated neural quieting, reversibility, homeostatic regulation. When deprived, these states were compensated for later. This compensation is crucial. It reveals that sleep is not optional. It is regulated internally, demanded by the system itself. Environmental cues continued to shape timing. Light remained influential, particularly for surface-dwelling organisms. Darkness signaled safety for withdrawal. Internal clocks aligned sleep-like states with nightfall. Yet sleep was not identical to darkness. In some species, sleep occurred during the day. In others, it was fragmented. The internal need for sleep could override external conditions. This independence marks a significant shift. Rest had become internalized as sleep. Within the nervous system, distinct patterns of activity emerged. Some states featured slow, synchronized signals. Others involved faster, irregular activity. These patterns alternated, forming cycles within sleep itself. These cycles appear early in evolution. Even animals without complex brains show alternating neural states during rest. This suggests that sleep architecture is ancient. It did not arise to serve a single function. It supports many. Energy conservation remains important, but it is no longer the sole driver. Neural repair, synaptic regulation, and memory processing all contribute. Sleep allows the nervous system to recalibrate. Connections strengthened during activity are adjusted. Redundant signals are weakened. Noise is reduced. Efficiency improves. Without these adjustments, neural systems become unstable. Behavior deteriorates. Survival suffers. As awareness gradually emerged, it did not create sleep. It encountered it. Conscious experience learned to fade within a state that already existed. This fading was not a loss. It was a transition. The organism withdrew from the immediate world, trusting internal systems to maintain order. This trust was earned over millions of years. Sleep became a place where the nervous system could work without interruption. A protected interval, a recurring quiet. As this chapter unfolds, sleep remains simple but recognizable. It is no longer just cellular restraint. It is a whole body state, still reversible, still responsive, still anchored to ancient rhythms. In the next chapter, sleep will deepen further. Awareness will grow more complex. Dreams will appear. But here, sleep has just found its shape. And it settles into that shape quietly, as it always has. As sleep continued to take shape within living systems, its presence became increasingly difficult to separate from the nervous system itself. What had once been a loose coordination of quieter intervals now began to resemble a structured state, entered and exited with regularity. This structure did not impose rigidity. It allowed flexibility within bounds. Sleep could lengthen or shorten depending on need. It could fragment or consolidate. Yet it remained recognizable, demanded again and again by the system. One of the earliest advantages of this structured state was protection from sensory overload. Nervous systems that processed information continuously faced a problem. Signals accumulated. Noise interfered with meaning. Without interruption, the distinction between important and unimportant input blurred. Sleep offered relief. By dampening sensory channels, it reduced the flow of incoming information. By quieting motor output, it limited unnecessary movement. The organism turned inward, not to escape the world, but to preserve its ability to engage with it later. In this inward state, neural activity did not cease. It changed character. Instead of responding to external stimuli, circuits interacted primarily with one another. Patterns formed, dissolved, and reformed. Activity became more coordinated across regions. These internal interactions laid the groundwork for integration. Information gathered during periods of wakeful engagement was reorganized. Associations were strengthened or weakened. Responses were refined. This process occurred without awareness. It did not require intention. It followed rules embedded in circuitry and timing. In organisms with simple nervous systems, these rules were minimal. Patterns were basic. Yet even here, the benefits were evident. After sleep-like states, responsiveness improved. Coordination sharpened. Errors decreased. Deprivation revealed the cost of omission. When organisms were prevented from entering these states, function deteriorated. Movement became erratic. Sensory processing faltered. Recovery required extended periods of rest. This rebound effect underscored an essential truth. Sleep was not optional. It was regulated internally, enforced by homeostatic pressure. As nervous systems expanded, this pressure intensified. Larger networks accumulated more activity during wakefulness. They required longer or more frequent periods of reorganization. Sleep adapted accordingly. In some lineages, sleep became consolidated into long intervals. In others, it remained distributed throughout the day. Environmental pressures influenced these patterns. Predation risk, resource availability, and habitat structure all played roles. Yet across this diversity, sleep retained its core features. It reduced responsiveness. It involved coordinated neural change. It was reversible. It was compensated for when lost. These features define sleep across the animal kingdom. Within sleep, further differentiation emerged. Neural activity did not remain uniform throughout the entire interval. Instead, it shifted between distinct modes. Some modes were characterized by slow, synchronized signals sweeping across neural tissue. Others featured faster, irregular activity resembling wakefulness, but detached from external input. These alternating modes served different functions. Slower patterns supported restoration. They allowed widespread coordination. They facilitated metabolic recovery and synaptic recalibration. Faster patterns supported integration. They replayed recent experiences. They strengthened useful connections. They prepared the organism for future challenges. These cycles appeared early. Even animals without complex brains displayed alternating patterns during sleep-like states. This suggests that the architecture of sleep is ancient, layered atop earlier rhythms rather than replacing them. The emergence of these cycles also hints at the origin of dreaming. Dreaming, in its earliest form, was not narrative. It was activity without input. Neural circuits fired in patterns shaped by past experience, unconstrained by immediate reality. These patterns allowed the nervous system to test possibilities safely. Movements could be rehearsed without risk. Associations could be explored without consequence. Such internal simulation improved adaptability. It did not require awareness. Awareness would come later. As organisms became capable of more complex behavior, the benefits of internal simulation grew. Sleep became a space for refinement, where responses could be tuned without danger. This refinement contributed to learning. Behaviors that led to success were reinforced. Inefficient patterns faded. Over time, this process increased behavioral sophistication. Sleep, once a simple coordination of quiet, became a driver of complexity. Yet it remained grounded in ancient needs. Energy conservation still mattered. Repair still mattered. Timing still mattered. Sleep did not abandon its origins. It expanded upon them. As awareness slowly emerged, it encountered sleep not as an invention, but as a pre-existing landscape. Conscious experience learned to enter and exit this landscape. At first, this transition was gradual. Responsiveness faded slowly. Awareness dimmed rather than vanished. The boundary between waking and sleep remained porous. Even today, traces of this porosity remain. Drowsiness, half-awareness, and fragmented sleep echo earlier stages of evolution. In these states, the nervous system balances engagement and withdrawal. Awareness loosens its grip without fully releasing it. Such states reveal sleep as a continuum rather than a switch. This continuity reflects its history. Sleep was never designed to exclude awareness completely. It simply reduced external engagement when internal work took priority. As organisms grew capable of sustained awareness, sleep adapted to protect both body and mind. Withdrawal from the external world reduced vulnerability during internal processing. Muscles relaxed, posture stabilized, movement slowed. This physical stillness complemented neural quieting. Together, they created a safe interval. Within this interval, repair extended beyond individual cells. Tissues recovered. Immune processes intensified. Growth hormones were released in greater abundance. Sleep became a time of rebuilding. This rebuilding was not visible from the outside. It occurred quietly, steadily, guided by rhythms older than awareness. Across species, the details varied. Some slept while floating. Others slept standing. Some slept with half their nervous system active. Others withdrew almost entirely. Despite these differences, the underlying logic remained the same. sleep balanced exposure and restoration. It allowed organisms to live actively without being consumed by activity. As ecosystems grew more complex, synchronized sleep patterns influenced interactions. Predator and prey adapted to one another's rhythms. Activity windows narrowed or expanded. Night became a shared interval of change. In many environments, sleep aligned with darkness not because darkness caused sleep, but because darkness offered protection. Reduced visibility lowered predation risk. Cooler temperatures conserved energy. Sleep fit naturally into these conditions. Yet sleep could persist even in constant light or darkness. Internal clocks maintained timing. This independence ensured continuity. Sleep was now fully established as a biological state, not universal in expression, but universal in necessity. As this chapter continues, sleep stands at the threshold of subjective experience. Awareness is present, but not dominant. The nervous system has learned to quiet itself without harm. In the next unfolding, sleep will take on new dimensions. Dreams will grow richer. Consciousness will deepen. But here, sleep has already secured its place. A structured withdrawal, a coordinated stillness, a legacy of rhythm carried forward into every waking life. As this legacy continued, sleep grew more deeply interwoven with the body as a whole. No longer confined to neural circuits alone, it became a systemic state, influencing nearly every physiological process. Heart rate slowed, breathing deepened and became more regular. Body temperature shifted subtly downward. These changes were not imposed externally. They arose from internal coordination, guided by the same rhythms that shaped neural quieting. This coordination reduced energy expenditure across the organism. Muscles relaxed. Digestive activity adjusted. Resources were redirected toward maintenance and repair. In this state, the boundaries between systems softened. Signals that remained compartmentalized during wakefulness flowed more freely. Hormonal patterns changed. Immune activity intensified. Growth and restoration accelerated. Sleep provided time not only for the nervous system to reorganize, but for the body to heal. These processes unfolded slowly. They required uninterrupted intervals. Fragmentation reduced their effectiveness. This sensitivity explains why sleep deprivation affects the body so broadly. When sleep is shortened or disrupted, repair is incomplete. Errors accumulate. Balance erodes. Across evolutionary time, organisms that protected their sleep gained resilience. Those that could not suffered reduced longevity and reproductive success. Thus, sleep became guarded. Behavior adapted to support it. Sheltering behaviors emerged. Safe resting places were sought. Postures minimized vulnerability. In some species, social structures provided protection during sleep. These behaviors did not create sleep. They evolved to preserve it. As animals became more mobile and more aware, the risks associated with sleep increased. Vulnerability during reduced responsiveness posed a challenge. Evolution responded by refining sleep architecture rather than abandoning sleep altogether. Partial sleep emerged. Unihemispheric sleep allowed one side of the nervous system to remain alert, while the other rested. Fragmented sleep reduced the duration of vulnerability at any one time. These adaptations demonstrate the strength of sleep's necessity. Even when dangerous, it could not be eliminated. It could only be reshaped. The nervous system learned to negotiate compromise. Sleep remained essential, but its expression adapted to context. In aquatic animals, buoyancy allowed sleep to occur while drifting. In terrestrial animals, posture and environment mattered more. Limbs tucked inward, bodies aligned for stability. Each adaptation preserved the core functions of sleep while addressing ecological demands. As awareness grew richer, the experience of entering sleep became more distinct. Transitions lengthened, thresholds became clearer. The fading of external attention was felt, even if not yet interpreted. This fading marked a new development. Sleep was no longer only a biological process. It was becoming a subjective one. Yet subjectivity did not alter sleep's purpose. It merely accompanied it. Within sleep, internal activity continued its work. Neural replay grew more complex. Sequences of activity reflected recent experience more clearly. Associations strengthened, skills refined. These changes improved waking performance. Animals navigated environments more efficiently. Learned behaviors stabilized. Memory extended beyond immediate experience. Sleep supported learning, not by adding new information, but by integrating what had already been encountered. This integration reduced cognitive load during wakefulness. Responses became more automatic. Attention could be directed toward novel stimuli. In this way, sleep expanded the capacity for awareness without increasing its burden. As cycles within sleep became more pronounced, the alternation between different internal states gained regularity. The nervous system moved predictably between deeper and lighter phases. This predictability allowed fine-tuning. Different processes aligned with different phases. Some favored deep coordination. Others favored integration and rehearsal. Sleep became layered, not a single state, but a sequence. This sequencing reflects sleep's evolutionary history. Each layer corresponds to an earlier function, preserved rather than replaced. Deep phases echo ancient restorative stillness. Lighter phases echo early neural replay. Together, they form a coherent whole. As this structure stabilized, sleep could support increasingly complex minds. Awareness, when it arrived more fully, found sleep already capable of sustaining it. Dreams would soon emerge as experiences rather than mere neural patterns. But even before that transition, sleep had achieved something remarkable. It had reconciled activity and stillness. It had allowed life to be dynamic without burning itself out. It had transformed rest into a living process. As this chapter continues toward its close, sleep stands no longer as a background rhythm, but as a central pillar of biological organization. It is ancient. It is adaptive. It is unavoidable. And it prepares the way for the inner worlds that will soon appear. As sleep settled into this central role, its influence reached even deeper into the rhythms of life. The timing of sleep began to shape not only recovery, but identity itself. When organisms slept, and how long they slept, became defining features of their interaction with the world. No two species slept in exactly the same way. Some rested briefly and often. Others withdrew for long, uninterrupted intervals. These differences reflected ecological realities, yet they all obeyed the same internal logic. Sleep adjusted to circumstance without losing its core purpose. This adaptability is one of sleep's quiet strengths. Rather than enforcing a single pattern, it allowed variation within constraint. The nervous system demanded restoration, but it permitted many paths to achieve it. As a result, sleep became woven into evolutionary niches. Nocturnal animals aligned their wakefulness with darkness. Diurnal animals aligned sleep with night. Crepuscular species balanced activity at the margins. Sleep did not dictate behavior, it supported it. Through this support, sleep influenced sensory priorities. Vision sharpened in species active during low light. Hearing and smell grew more prominent where visibility faded. Sleep timing helped sculpt these adaptations by shaping when the nervous system was most engaged. In this way, sleep participated indirectly in the evolution of perception. As awareness grew more complex, transitions into sleep became moments of internal negotiation. External attention loosened gradually. The boundary between waking and sleeping softened. Sensory impressions lingered even as responsiveness declined. These transitional states preserved continuity. They allowed awareness to fade without abrupt loss. They reduced disorientation upon waking. Such gentleness was adaptive. Sudden loss of responsiveness could be dangerous. Gradual withdrawal preserved safety. The nervous system learned to let go carefully. Within sleep, internal patterns grew richer. Neural activity traced pathways shaped by experience. Repetition strengthened familiarity. Variation introduced flexibility. These processes occurred beneath awareness, yet they shaped it profoundly. When the organism woke, it carried forward subtle changes. Perception shifted, responses adjusted, learning accumulated. Sleep thus became a silent teacher, not instructing directly, but refining indirectly. Over evolutionary time, this refinement enabled increasingly sophisticated behavior. Navigation improved, social interactions stabilized, communication grew more nuanced. Sleep supported these advances by maintaining internal coherence. As social behavior emerged, sleep adapted once more. Group living introduced new pressures. Shared sleeping spaces offered protection, but required synchronization. Activity cycles aligned within communities. This alignment reinforced social bonds. Shared rhythms fostered predictability. Cooperation became easier when individuals rested and woke together. In some species, vigilance rotated. Some slept while others remained alert. This sharing of vulnerability allowed sleep to persist even in exposed environments. Such arrangements demonstrate sleep's negotiable nature. It bends to circumstance without breaking. As brains grew larger, the cost of wakefulness increased. Neural activity consumed substantial energy. Sleep compensated by providing extended intervals for recovery. This compensation supported brain expansion. Without sleep, larger brains would have been unsustainable. In this sense, sleep enabled intelligence. It did not create thought, but it made thought viable. As awareness deepened, the experience of sleep itself began to carry meaning. Dreams emerged not only as neural patterns, but as felt experiences. Images, sensations, and emotions unfolded within the protected space of sleep. These experiences were not yet narratives in the modern sense. They were fragments, impressions, rehearsals. Yet they marked a turning point. Sleep had become an inner world. This inner world remained anchored to ancient functions. Dreams reflected waking concerns. They reorganized experience. They explored possibility. Even now, sleep did not abandon its original purposes. Repair continued. Restoration persisted. Timing remained essential. The addition of inner experience layered new significance onto an old foundation. As this chapter approaches its close, sleep stands fully formed as a biological state. It is no longer merely rest. It is no longer only coordination. It is a space where life withdraws to sustain itself. A space protected by rhythm. A space shaped by evolution. The next unfolding will explore what happens when this space becomes vivid, symbolic, and deeply human. For now, sleep remains what it has always been. A quiet necessity. A negotiated stillness. A gift earned through time. Chapter 3. When sleep became an inner world. Sleep did not remain only a biological necessity. As awareness grew more complex, sleep became a place. Not a physical place, but an internal one. a space where experience continued without the guidance of the outside world. A space shaped by memory, emotion, and imagination, all moving quietly beneath the surface of consciousness. This transformation did not arrive suddenly. It unfolded gradually, layered atop the ancient rhythms that had always governed rest. The nervous system did not abandon its earlier functions when inner experience emerged. Repair, coordination, and restoration continued, steady and reliable. What changed was the addition of meaning. Within sleep, neural activity began to organize itself into patterns that were not directly tied to immediate survival. Images appeared, sensations echoed. Fragments of waking life were replayed, reshaped, and recombined. These early dreams were not stories. They lacked structure and narrative. They were impressions, movements, emotional tones drifting through the quiet mind. Yet even these fragments served a purpose. They allowed the nervous system to explore possibility without consequence. Actions could be rehearsed without risk. Associations could be tested without commitment. Emotional responses could be softened or strengthened in a protected space. Dreaming, in this earliest sense, was an extension of learning. It built upon the replay and integration that had already defined sleep. What changed was the involvement of awareness. Consciousness did not guide these processes. It witnessed them. This witnessing altered the experience of sleep. The boundary between waking and sleeping grew more distinct. Entry into sleep became a descent rather than a fading. Exit became a return. With this distinction came memory of the journey. Some dreams lingered after waking. Others dissolved immediately. Both outcomes were part of the same process. What mattered was not recall, but function. Dreams organized emotional experience. They reduced the intensity of waking concerns. They integrated memory with feeling, allowing organisms to carry forward lessons without being overwhelmed. As brains expanded further, dream content grew richer. Sensory regions contributed vivid imagery. Emotional centers infused dreams with feeling. Motor planning areas simulated movement. Yet the body remained still. This stillness was essential. It protected the organism while the mind explored. Mechanisms evolved to separate internal simulation from external action. Muscle tone decreased. Reflexes were suppressed. The nervous system learned to imagine without moving. This separation marks one of sleep's most delicate achievements. It allowed consciousness to wander safely. Across species, the balance between movement and stillness varied. Some animals retained partial mobility during dreams. Others withdrew almost completely. Each solution reflected ecological context. Despite this variation, the core pattern remained. Dreaming occurred within sleep. Sleep protected dreaming. As social complexity increased, dreams began to incorporate relationships. Faces appeared, interactions replayed. Social bonds were rehearsed internally. These rehearsals improved cooperation. They reduced conflict. They allowed emotional processing without immediate consequence. Sleep became a space where social life could be maintained quietly. For humans, this space grew especially rich. Language entered dreams. Memory became narrative. Symbols emerged. Dreams reflected culture, history, and personal identity. Yet even in their most elaborate forms, dreams retained their ancient roots. They remained tied to regulation, integration, and balance. Dreaming did not replace sleep's biological functions. It accompanied them. As modern humans emerged, sleep patterns stabilized around Earth's rotation. Night became the primary interval for withdrawal. Artificial light extended wakefulness, but internal clocks remained influential. Sleep pressure accumulated with time awake. The need for rest asserted itself regardless of intention. This persistence reveals sleep's depth. It cannot be overridden indefinitely. It is not a habit, it is a requirement. Within modern sleep, ancient cycles continue. Slow phases alternate with lighter ones. Deep restoration gives way to vivid dreaming. The sequence repeats night after night. These cycles echo earlier stages of evolution. Deep phases reflect ancient cellular repair. Lighter phases reflect early neural replay. Dreams reflect the emergence of inner experience. Sleep, in this way, contains history. Each night, the nervous system revisits its past. Not consciously, but structurally. As the night progresses, the balance between restoration and dreaming shifts. Dreams grow longer toward morning. Awareness brushes closer to waking. This timing supports transition. It prepares the organism to re-enter the world. Waking does not erase sleep. It builds upon it. Mood stabilizes, memory consolidates, attention sharpens. The benefits of sleep extend beyond the night. They shape the day. Across a lifetime, sleep changes. Infants sleep deeply and often. Children dream vividly. Adults balance demands. Older individuals sleep more lightly. These changes reflect shifting priorities. Growth gives way to maintenance. Repair becomes more selective. Yet the need for sleep never disappears. Its form adapts, but its presence remains. Sleep continues to serve as a bridge between body and mind, between past and present, between effort and recovery. As this final chapter draws toward its close, sleep stands revealed not as an escape from life, but as one of its central expressions. Life does not pause during sleep. It reorganizes, it reflects, it prepares. Each night, the planet turns. Darkness arrives. Millions of minds withdraw together, entering their private inner worlds. These worlds differ, yet they rest upon the same ancient foundation: rhythm, stillness, return. Sleep carries life forward, quietly, as it always has. As this quiet carrying continues, the inner world of sleep grows more familiar, not through repetition, but through return. Each night invites the nervous system to step away from immediate demands and enter a space shaped by memory and rhythm rather than urgency. In this space, time behaves differently. Moments stretch and compress. Sequences loosen. Events that occurred far apart during the day may meet within a single dream. This altered sense of time reflects the way the brain reorganizes experience when freed from external clocks. The internal rhythms that guide sleep remain steady, yet awareness moves fluidly within them. This fluidity allows emotional experiences to soften. Intensity disperses. Meaning emerges gradually rather than sharply. Sleep does not solve problems directly. It reframes them. By revisiting experience without immediate consequence, the mind gains perspective. Patterns become visible. Connections form quietly. This reframing is especially important for emotional balance. Strong feelings generated during wakefulness can linger, taxing attention and energy. Within sleep, these feelings are revisited in a gentler form. Their edges blur, their weight lessens. Through this process, emotional memory is integrated rather than erased. The experience remains, but its charge diminishes. Dreams serve this function subtly. They need not be remembered to be effective. Their work occurs whether or not awareness recalls it. This is why forgotten dreams still matter. They have already done their work. As the night unfolds, the balance between deeper and lighter phases shifts. Early hours favor restoration, later hours favor dreaming. This progression mirrors the arc of life itself, moving from preservation toward expression. In the later phases of sleep, awareness drifts closer to the surface. Dreams grow more vivid. Sensory detail increases. The mind rehearses waking life more directly. This rehearsal eases the transition into morning. It prepares perception to re-engage. When waking arrives, it does not interrupt sleep abruptly. It rises from it. The boundary between inner and outer worlds dissolves gradually. Awareness returns carrying the quiet work of the night. This return is often subtle. Its effects are felt more than noticed. Clarity improves, mood steadies, attention sharpens. Sleep has already done its work. Across cultures and histories, humans have noticed the mystery of this inner world. Stories have been told, symbols interpreted, meanings sought. Yet sleep itself remains indifferent to interpretation. Its function does not depend on understanding. The body sleeps whether or not the mind assigns meaning to the experience. This indifference is part of sleep's stability. It does not require belief. It does not respond to intention alone. It follows rhythm. Even when modern life disrupts natural cycles, sleep asserts itself. Pressure accumulates, fatigue deepens, attention falters. Eventually, withdrawal becomes unavoidable. This inevitability reflects sleep's ancient authority. No technology has replaced it. No adaptation has removed it. Sleep persists because it is woven into the architecture of life. As humans altered their environment, extending light into night and activity into hours, once reserved for rest, sleep adjusted without surrendering its core. Schedules shifted, durations changed, yet the internal demand remained. Circadian rhythms continued to influence hormone release, body temperature, and alertness. Even in constant light, the body carried the memory of night. This memory traces back beyond culture, beyond species, to the earliest living systems that learned to pace themselves against the planet's turning. In this way, sleep connects modern minds to ancient life. Each night becomes a quiet inheritance. The act of sleeping is an act of continuity. It links individual experience to a shared biological past. As age advances, sleep changes once more. The inner world becomes lighter. Awakenings increase. Dreams may fragment. These changes reflect shifting priorities within the body. Maintenance takes precedence. Deep restoration becomes more selective. Yet even lighter sleep retains its purpose. The nervous system continues to reorganize. The body continues to repair. Sleep adapts without abandoning its role. Throughout all stages of life, sleep remains a companion rather than an obstacle. It does not steal time, it returns it. Time spent asleep supports time spent awake. This exchange is quiet and reliable. As the final moments of this story settle, the image widens once more. Night spreads across the planet. Lights appear and fade. Activity slows in countless forms. Forests grow still. Oceans shift their surface patterns. Cities dim. Within homes, caves, burrows, and canopies, bodies rest. Minds turn inward. Different worlds unfold, yet all follow the same rhythm. The planet continues to turn. Sleep continues to arrive. And life continues, supported by the quiet work done in darkness. As darkness settles again and again, sleep continues to shape the way awareness relates to the world. It does so gently, without instruction, through repetition rather than command. The mind learns over time that there is a place to set things down. Within this place, effort loosens, attention softens, the need to respond recedes. What remains is presence without demand. This quality of presence is not emptiness, it is fullness without urgency. Sensations arise and pass without insistence. thoughts drift without requiring resolution. Sleep offers this condition not as an escape, but as a restoration of proportion. During waking life, perception narrows around goals. The world is filtered through intention. In sleep, intention dissolves. Experience widens. This widening allows the nervous system to rebalance. No single concern dominates. No single memory demands priority. Everything becomes part of a larger field. Within that field, patterns reorganize themselves naturally. This reorganization is subtle. It does not announce itself. It leaves no clear marker. Yet its effects are evident upon waking. Problems feel less rigid. Emotions feel more manageable. The body feels more aligned with itself. Sleep has not changed the external world. It has changed the internal relationship to it. This change is one of sleep's most enduring contributions. By restoring proportion, it preserves perspective. Across cultures, people have sensed this effect intuitively. Sleep has been associated with renewal, insight, and clarity. Not because sleep delivers answers, but because it clears the space in which answers can appear. Even when dreams are fragmented or forgotten, this clearing occurs. The nervous system does not require narrative to reorganize. It requires time, rhythm, and safety. Sleep provides all three. As the body rests, the brain continues to coordinate its vast network of connections. Signals strengthen where they are useful. They weaken where they are redundant. Balance is restored without calculation. This quiet optimization supports learning across a lifetime. Skills practiced during the day are refined at night. Emotional experiences are integrated. Habits stabilize. Through sleep, experience becomes part of the organism rather than a burden upon it. This integration supports resilience. Life's unpredictability is easier to navigate when internal systems remain flexible. Sleep maintains that flexibility. It prevents the nervous system from becoming fixed in a single mode of response. It allows adaptation to remain possible. In this sense, sleep is a guardian of change. It ensures that growth does not harden into rigidity. As individuals age, this function becomes increasingly important. The accumulation of experience can narrow perspective. Sleep counteracts this narrowing by continuing to reorganize and rebalance. Even lighter sleep contributes. Even brief rest intervals matter. The form of sleep may change, but its influence persists. In moments of illness or stress, sleep asserts itself more strongly. The body demands withdrawal. Energy is redirected toward repair. This demand reflects sleep's original role as protection. Long before it became an inner world, sleep was a shield. That shield remains. Modern life often resists this withdrawal. Schedules press forward. Light extends the day. Attention remains engaged. Yet the need for sleep accumulates quietly. Eventually, the body insists. This insistence is not failure. It is fidelity to life's deeper rhythm. Sleep does not negotiate endlessly. It arrives. When it does, it restores the conditions necessary for continued engagement. The alternation between waking and sleeping is not a conflict. It is a partnership. Waking gathers experience. Sleep integrates it. Together, they sustain awareness across time. As this final chapter continues to unfold, the scale widens once more. Individual nights blend into seasons. Seasons blend into years. A lifetime of sleep accumulates, shaping a life quietly from within. Each night contributes a small adjustment. Over years, these adjustments compound. Memory becomes organized. Emotional patterns stabilize. Identity takes shape. Sleep participates in the making of a self, not through intention, but through repetition. As the planet continues its steady rotation, This participation repeats across billions of lives. Different species, different minds, different inner worlds, yet all rely on the same ancient process: withdrawal, reorganization, return. This cycle has no endpoint. It does not aim toward completion. It simply continues. Night after night, generation after generation. As the listener rests within these words, the same process is already underway. The mind softens, attention drifts. The boundary between outer sound and inner experience becomes less distinct. This is not something to observe. It is something to allow. Sleep does not require effort. It arrives when space is made. And in that arrival, life continues its quiet work, as it always has. As the night lengthens, sleep settles into a steady presence rather than an event. It is no longer something that begins or ends sharply. It becomes a condition, sustained gently over time. Within this condition, awareness drifts without direction. Thoughts loosen their grip. Images arise and dissolve without demand. The mind is not trying to arrive anywhere. It is simply resting within itself. This resting is not inactivity. Beneath the surface, countless processes continue, coordinated and precise. The nervous system adjusts its internal balance. The body attends to maintenance that cannot be rushed. Sleep makes room for these processes by reducing interference. During waking hours, attention pulls resources outward. Muscles prepare for movement. Senses remain alert. Decisions accumulate. Sleep withdraws these demands. In this withdrawal, energy is freed. It is directed inward, where repair and renewal unfold slowly. Cells replace worn components. Neural connections adjust their strength. Hormonal signals follow rhythms tuned over millions of years. None of this requires instruction. The body knows how to do this because it has always done it. As minutes pass into hours, sleep deepens and lightens in waves. These waves do not disrupt rest, they sustain it. Each phase contributes something different, yet all are part of a single movement. Deeper phases support widespread coordination. The nervous system synchronizes activity across large regions. This synchronization creates coherence. Lighter phases invite imagination. Neural activity becomes more varied. Associations form freely. Dreams arise, not as stories to follow, but as movements of feeling and image. These dreams need not be understood. They are not messages to decode. They are expressions of integration. Within them, recent experiences mingle with older memories. Emotions shift shape. Possibilities are explored quietly. When the mind returns toward wakefulness, it does so carrying these adjustments. They are subtle, but cumulative. Night after night, they shape how awareness meets the world. Over weeks and months, sleep influences temperament. Patience grows where rest is sufficient. Resilience strengthens. Reactivity softens. These changes are not dramatic. They are gradual, like erosion or growth. Sleep works on long timescales. It does not aim for immediate results. It prepares the ground. As years pass, the accumulation of nights becomes a quiet foundation beneath a life. Memory organizes itself. Emotional patterns stabilize. Habits take root. The self that emerges is shaped not only by waking experience, but by how that experience is integrated during sleep. This integration is ongoing. It does not conclude. Even in advanced age, sleep continues its work. Though lighter and more fragmented, it still reorganizes, still repairs, still restores proportion. Moments of rest remain valuable. Short intervals still matter. The form changes. The function persists. Sleep adapts as life adapts. When illness arrives, sleep often deepens. The body draws inward, conserving energy. Repair becomes urgent. This response reflects sleep's original role as protection. Long before it became an inner world, sleep was a refuge. That refuge remains available. In times of stress, the need for sleep increases. The nervous system seeks relief from sustained activation. Withdrawal becomes necessary. This need is not weakness. It is intelligence expressed through rhythm. Modern environments sometimes resist this rhythm. Artificial light extends the day. Stimulation persists. Attention is pulled outward late into the night. Yet the body retains its memory of darkness. Hormonal cycles still respond to the absence of light. Temperature still shifts. Sleep pressure still accumulates. Eventually, the call to rest becomes unmistakable. When honored, it restores balance. When resisted, imbalance grows. Sleep does not punish. It simply reflects conditions. As the world outside quiets, countless lives enter their own intervals of withdrawal. Different species, different forms, different inner experiences. Some sleep lightly, alert to subtle changes. Others withdraw deeply, unreachable for long hours. Some alternate, sharing vigilance. Despite these differences, the shared pattern remains. Engagement gives way to stillness. Stillness supports renewal. Renewal prepares return. This pattern repeats across landscapes and oceans, forests and cities. Night spreads unevenly, following the curve of the planet. As it moves, sleep follows. In one place, dawn approaches. In another, night deepens. At every moment, somewhere on Earth, minds are turning inward. This continuity links all living beings. Sleep is a shared condition, even when experienced alone. It connects individuals to the broader movement of life. As the hours of darkness continue, language becomes less necessary. Explanation recedes. What remains is rhythm. Breath slows, the body settles, thoughts thin. Awareness drifts. Nothing needs to be held, nothing needs to be solved. Sleep asks only for space. In that space, life continues its quiet work, undisturbed. The planet turns. Darkness arrives and departs. Rest returns again. And in this endless repetition, life endures, gently, without urgency, carried forward by the simple wisdom of pause.